Hi, this video we're going to be talking about nominal versus actual sizes. Well, when we go to hardware store, we may buy the 2x4 piece of lumber, and if you were to measure the dimension of this cross section, right? And this rectangle is actually not 2 inches by 4 inches. The actual width is about 1.5 here and 3.5 right here. So that's why we refer, but that's why we call this 2x4 considered as nominal size. And the actual size is going to be 1.5 by 3.5, right? But why do they refer as 2x4? Because the manufacturers of those engineered parts or numbers, they use round up the numbers, so that's easier for people to remember, right? Okay, so that's our nominal versus actual size. But when you solve the problem in the future for engineering classes, you really need to know the actual size of those different engineering parts instead of using the nominal size. For example here, let's look at example of nominal size versus actual size of some engineering products. This is copper tubing, and the copper tubing, the cross section is going to be something like this, right? It's kind of donut shape, and in the middle is a hollow, and those are made of copper, and it's going to be 3D. Okay, so if it's 1/4 nominal size, what does it mean? They actually mean, it doesn't mean 0.25 as 1/4. The outside diameter, so I'm going to label this using a different color. Outside diameter, that's going to be, we call this OD. That's our OD. It's 0.375. The inside diameter, ID, is going to be right here. That's our ID. That's 0.05. Okay, so in order to figure out the wall thickness, knowing those two numbers, we can, even though this table give us that information. Let's just try one for fun. So you're going to use outer diameter, 0.375, minus inner diameter. And you realize when you use this outer diameter minus this inner diameter, which is right here, then what's left is actually 2 of the wall thickness, right? So to solve that, you have to divide it by 2. Oops, divide by 2. That's going to be your thickness of the wall. So when you calculate that, you get 0.07 here, divided by 2, so it's 0.035 inch. Exactly the same number as this one here, okay? Then they give us this column is flow cross section. Well, we know the flow only going this hollow part. That's going to be the flow cross section area, and it's a circle, so it's going to be pi r square, and r here is inner circle. Sometimes we use diameter, so radius is diameter, inner diameter over 2. So we use pi d squared over 4. That's another expression for area. So in that situation, we can plug it in. For this situation, the inner diameter is 0.305 square. And when we calculate that, I would suggest you to try that. Pause, see what you got. And you get 0.073 inch square, happen to be the same number as listed in the table. So that's for copper tubing type K. That's for high pressure temperature usage. And there are other copper tubing they can use for HVAC, and they call type L. And they give us the similar columns: outer diameter, inner diameter, and the thickness, and the cross-section area. So as you can notice, if it's 1/4 inch, they have slight different inner diameter for this one compared to type K versus type L, but none of them is 0.25 inch as listed as nominal. So as engineer, you're going to look up this table, finding corresponding actual dimension right here. Now let's look at the third kind. It's type M. That's for HVAC and water application, domestic water application. And if you start with 3/8, and the outer is 0.5, inner is 0.5, and you can find wall thickness and flow cross section as well. Now let's look at another type of engineering product. We looked at the piping earlier. Now let's look at I-beam. I-beam is often used for structure, and this I-beam, the reason you called I-beam is because it looks like a letter I, right? And for this I-beam, we have SI unit, so also have US unit. Okay, for SI unit, look at this notation here. It's quite helpful. That notation said the nominal depth, that means there are two numbers here. The first number, 460, that means the depth. And that's nominal depth, okay? So nominal depth is basically from here to here, but 460, that's the nominal. The actual size is 463. So this is nominal. The second number, what does that indicate? That means mass per 1 meter. So that means 113 kilogram of mass per every single meter of this I-beam. It has that much mass to it. I mean, that's critical for us to know, right? That's basically telling us how much material was used to build this beam. Okay. Now let's look at, so here the second column is flange width. That's telling us this, that's here, flange width. And area, it's a cross-section area of this entire I shape. Okay. Now let's look at US system. They have the similar column, depths, flange, and area, but this one, they have a different unit. The first number, it's also nominal depth. But it's no longer in millimeter dimension. This is going to be in unit of inch. So that means 18 inch. But the actual size is 18.21. Okay. What's the second number indicate? The second number is also what's the mass over per foot. So that means it's 76 pound mass per length per foot. That also, remember we learned before, 1 pound mass was 1 pound and 4 ounces. So that means if you converted the mass to weight, that's 76 pound force per foot. Okay, so that's the I-beam. Through this couple of examples, hopefully we understand the nominal versus actual size. All right, see you next time. Bye.